Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. I have cos x divided by cos of x minus a, right? So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. That's my y. I know that my y is not in a very simple format whose antiderivative I know from first principles. So the job in hand is to simplify y, right? Now I notice that I have a cos of x minus a in the denominator and I have a cos of x in the numerator, right? So whenever you see such type of problems, right, it is always better if you can, by the method of substitution, bring the more complex term. I don't have better words to put this across. Bring the more complex term to the numerator, right? How do we do that? Again, by the method of substitution, when I do t equals x minus a, I can simplify my term in the denominator. So when I rewrite this, my x becomes equal to a plus t, right? I do t equals x minus a, my x becomes a plus t, and my dx becomes dt, right? I differentiate on either side. So now I go back to my y, and I'm going to rewrite my y as follows. My y becomes integral of, now I'm going to put back everything in terms of t. My numerator becomes cos of a plus t, right? And my denominator, which is cos of x minus a, becomes a cos t. And then I have my dx, which becomes a dt, right? So my y becomes integral of cos of a plus t divided by cos t into dt, right? Now you see that I can expand my numerator using the cos of a plus b formula, right? What happens here is my cos of a plus b can be rewritten as cos a cos b minus sin a sin b, right? So when I write my y, so that's my y, and you notice that I have a cos a cos t term and a sin a sin t term in the numerator, and I have a cos t term in the denominator, right? So I'm going to decompose this particular expression what I have, and I decompose this, what do I get? My first term, which is cos a cos t divided by cos t, becomes a cos a, right? And then because my cos t gets cancelled, and then my second term, which is sin a sin t divided by cos t, I'm going to keep it as it is, right? And you will understand why am I doing that. Now I can apply the sum rule of integration and break this down further. My y becomes nothing but integral of, my cos a is a constant, so I can pull that out with respect to the first expression, and I get an integral of dt. And then I come to the second expression, and observe me closely here, folks. I have a constant which is sine a, so let me pull that out. And I have an integral of sine t by cos t dt, which is nothing but a tan t dt. So the expression y post some rule of integration becomes cos a times integral of dt minus sine a times integral of sine t by cos t times dt, right? Now what is my sine t by cos t? It is nothing but a tan t, right? So what we have is integral of tan t dt there in the second part of y. And the reason why I wrote this again as integral of sine t divided by cos t in an interim step is for you folks to understand that integral of tan t dt is solved by the method of substitution, right? So I have a cos t in the denominator, and then I have a sine t dt in the numerator. and I leave it to you folks to determine what is that substitution that will help you solve for integral of tan t dt in case you don't remember the formula. But for now, I'm going to directly apply integral of tan t dt, right? So let's write down that my integral of tan t dt is nothing but ln of mod of secant t plus c, right? I go back to my y. My first part of y becomes t times cos A, and my second part of y becomes sine A times integral of sine t by cos t dt is nothing but integral of tan t dt, which is ln of mod of secant t plus c. I know that I cannot leave my answer in terms of t. I'll have to put back everything in terms of x. I go back, I look at what the original substitution I've made. It is t equals x minus a. So my first part of y becomes x minus a cos a minus sine a times ln of mod of secant of t becomes x minus a here again, and my constant plus c, right? So y equals x minus a times cos a minus sine a times ln of mod of secant of x minus a plus c, right? I'm going to highlight my final answer in pink. I hope you folks found my content useful. Please do subscribe to my channel and support. Thank you.